Today we're going to be working on the Mathematics Vision Project, Module 2, the 2.2 set. And so here we go. It says to graph a standard y equals x squared parabola, which is our parent function of a parabola. So we're going to go ahead and take the y equals x squared and use all of these inputs. So for example, -3 squared, -2 squared, -1 squared, and so on and so forth. We're taking all these x values as inputs to see what we get as outputs. And then once we say what's 3 times 3, it's 9, 2 times 2 is 4, 1 times 1, 0 times 0. We get all of these output values. Now notice that when we square a negative, negative times negative is still +1. Negative times -2. Still +4, still +9. So notice all of our outputs are positive when we're just squaring the inputs. Here I go graph it now. And it wants us to go put the starting point at 0, 0 on the origin right here, vertex. And then go put the dot 1, 1. And -1, 1. And then go put the dots 2, 4, -2, 4, and then 3, 9, and -3, 9. Now you might be like, how are you counting so fast? It's helpful on these graphs to have the 5 markers on there. So 1, 2, 3, 4, 5, 1, 2, 3, 4, -5. Get that scaling on your graph, 1, 2, 3, 4, 5. And don't forget to put the X and the Y. So the label and scaling can be helpful to have on there before you start graphing. Okay, connect that parabola now as best you can to be a U-shaped graph facing up. This is the parent of all parabolas, y equals x squared. Okay, so now state the vertex of the parabola, 0, 0, the origin is our vertex. And I circled it right there. Now they're asking us to then find a value for, that right there is a little Greek symbol. So if you're like, what the heck is that letter? It's basically like any other variable. We could call it variable w. But find a value for w such that the graph will have the specified number of x-intercepts. So if I've got a graph of y equals x squared as my parent function, right now it's only touching one time on the x-axis and y-axis. It has one x-intercept. It wants me to move this graph, to shift this graph so it has two. Notice if I took that whole parabola and shifted it down, for example, then it would touch 2 times. So I go ahead and say, find a value for w so that it would have 2 intercepts. I could say x squared minus any number. So I'm just going to pick -5. You pick any number. Next, it wants one with 1 intercept. Well, currently at y equals x squared, it has 1 intercept. So let's just move it right or left from there. So for this one to have 1 intercept, if the original parent graph has 1 intercept, we can just move it right or left, right? So here I go. I could literally just make this x minus any number, and that would move it right to, or I could make it x plus any number, and that would make it move left. So either way, moving it right or left along that axis still will give it 1 x-intercept. No x-intercepts means I want to move it up above the axis, not touching it all. So y equals x squared plus literally any number would work for that. Pause the video, try the next few. Okay, let's see how you did. Now taking the original parent function and flipping it upside down, that's the y equals -x squared. To have 2 x-intercepts, we want to move it slightly up. So -x squared, for example, plus 4, that would move it up enough to have 2 x-intercepts. Next, we want it to have one x-intercept. So again, just moving it right or left along that axis, we could move it x minus 2 squared or x plus 2 squared, moving it right or left. Finally, no x-intercepts. If it's an upside down parabola, I'm just going to want to move it down. So minusing any number to move it down would mean it does not touch the x-axis. So your answers for numbers 14 through 19 are going to vary. Okay, next, graph the following equations based on the vertex form of the parabola. I do want to just write it up here as a quick reference. Plus or minus a, that's your stretch in your orientation, x minus h squared plus k, where h is your horizontal shift, your x value of the vertex, and k is your vertical shift. Notice there isn't one right there. Okay, so back to this graph. Let's correct a couple things here. Okay. It's helpful to have the 5 markers, 1, 2, 3, 4, 5. Okay, so the vertex of the first one is that yellow and green highlight. Remember that our vertex is the opposite sign from the equation. So when it says x minus 1, my vertex is at positive 1. And when there's nothing at the back here, it means my vertex is going to be at 1, 0. So this is telling me to shift right 1, putting a dot at 1, 0. And then my parabola has the same 1 parent stretch. That means my parabola is going to grow by out 1, up 1, out 2, up 4, and out 3, up 9. And then connect it. And this is my parabola shifted right 1. Okay, next we have a vertex at right 1, up 1. So I go right 1, up 1 as my starting vertex point, and then it grows the same as the parent, out 1, up 1 on both sides. Out 2 from the vertex, 1, 2, 1, 2, 3, 4. Out 2, up 4 on both sides. Out 3, up 9 on both sides, connected. Next, this one's at right 1, up 1, but it has a stretch or an A value of 2. So when the stretch is 2, it's going up 2 times as fast as the parent. So let's check this out. Go right 1, up 1. There's my vertex, my HK. But then instead of going out 1, up 1, I'm going to go out 1, up 2. Out 1, up 2 on both sides. Actually, I think I can fit one more dot. Out 2, up 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, it's going to fit. So why is it up 8? It's normally y equals x squared. Y equals 2 squared is 4. Right? Normally out 2 is up 4 for this reason. But we're doing 2 times the normal. So my stretch is 2. That means I'm going to go up 2 times the normal 4 or 8. So out 2 is up 8. Next, I've got an h and a k of negative 3, 0. -3, -4, -1, 4. Notice the x value of the HK, that first value, is the opposite sign. So if this is a positive, this is -3. If this is a positive, this is -3. If this is a positive, this is -1. Do you see how it's the opposite sign of your x value? So we go back 1, 2, 3, 0, and then parent stretch. Out 1, up 1, out 2, up 4, out 3, up 9. Next, we go -3, -4. There's my starting vertex. This one is growing downward, parent stretch of 1. Out 1, down 1 on both sides. Out 2, down 4. Parent stretch, down. And finally, left 1, up 4 is my vertex. This has a downward stretch of a half. Out 1 is going to go down only half of 1. Out 2 would normally be down 4, so we're going to go down half of 4. It's a wider graph than our original parent because it's only going half as fast.